wait 2-3 minutes before we start?
Yeah, when she opens it, you'll see the numbers increase in terms of the participants. So click on participant list and you'll see the attendee number risen. So once you're satisfied that we have enough, you can go ahead. So over to you, Nikita, to take us live. Thanks.
Okay. Okay, and we're starting in 5, 4, 3, 2, 1. You can begin.
Good morning, everyone. A very warm welcome to this virtual demonstration event on electric vehicles. We are happy to see you here on this wonderful morning in November. Let us take you on a drive and answer a number of questions on electric vehicles that you all might have, starting from technology aspects, the types of vehicles that are available in the Caribbean, their performance, how charging and maintenance of these vehicles works, and why they are beneficial for you as vehicle owners, but also for us as the whole region. Let us start by looking into the importance of sustainable transportation. In most member states, the transportation sector is responsible for a large share of final energy consumption. That makes up 30 to 68% in the majority of member states. Final energy consumption can be lower with a few exceptional cases in like Trinidad or Haiti, where consumption is only between 8 to 12%. But in general, transportation sector is a huge consumer of energy, and road transport accounts for about 90% of this fuel use, with the vast majority of consumption also being accounted for by light-duty vehicles. A recent study for the Regional Energy Efficiency Strategy showed and estimated that about 70% of our road traffic could be electric or hybrid electric over the coming 15 years if we implement enough support measures to achieve this transition. It shows that there is a great potential for electric mobility in the whole region, and transport electrification is already happening. We have more than 500 electric vehicles on the roads within CARICOM, the majority of which currently is driven in Barbados. Transport electrification is also very beneficial for the region to reduce fuel import dependence and related costs, to protect our climate by reducing greenhouse gas emissions, and it helps cover all our mobility needs more efficiently with great performance and comfort for you as drivers and users of electric vehicles, and it helps to make our way of moving future-proof and forward-looking. So we will start this virtual demonstration event with a presentation from Dr. Curtis Boudou, who will introduce you to the regional framework for electric mobility, which is currently in development, the Regional Electric Vehicle Strategy. Dr. Boudou is assistant professor in the Utilities Engineering Unit at the University of Trinidad and Tobago. He has been a faculty member at UTT since 2004 and is a program coordinator for the Electrical and Electronics Engineering Diploma Program. He contributed towards the development of the Sustainable Energy Implementation Plan 2021-2030 for Trinidad and Tobago, National Energy Policy, and a number of other national initiatives and strategies. He's also the project manager for the electric bus project in Trinidad and Tobago, and he's the chairman of the Electric Vehicles Working Group that was convened by the CARICOM Energy Program. I will hand over to you, Dr. Boudou, right now to introduce all our participants to the Regional Electric Vehicle Strategy. You're welcome.
Thank you. Thank you so much, Cornelia. Can you please confirm that you are hearing me clearly and you can see my screen? Excellent. I am very excited and delighted to be here this morning to talk to you about what we call the REVS, the Regional Electric Vehicle Strategy for the CARICOM region. So before I get into what the REVS really is, I wanted to ask a very basic sort of personal question. Why should I own an EV? So there are three major reasons. It's cheaper to maintain, it has a lower fuel cost, and you have a lower carbon footprint. Now, we have some excellent speakers to follow that would really, and they will dive much deeper into these three reasons. but I wanted to bring to your attention that these are some of the major reasons why you should be interested in owning an electric vehicle. So the next question is, why should my country invest in EVs? So I gave you the reasons why you should, but why should your country? Well, Cornelia gave an excellent introduction to this. So in this graphic, we have the percentage of fuel used for the transportation sector in the Caribbean, in CARICOM more specifically. And you could see that for most nations in the region, we consume over 40% of our fuel for the purpose of transportation. And you have to keep in mind that this is imported fuel. So this fuel consumes valuable foreign exchange for us. And it would be an excellent idea to reduce this fuel usage, this imported fuel, and to use a fuel that is indigenous to the region. And electric vehicle technology allows this, whereby you could use renewable energy that is generated and fed into the grid, and that energy could be used to charge your car. So the cleaner the grid is, the more renewable energy you have, the lower your import for fuel for the purpose of transportation. So the next reason why your country should invest in EVs is because we made international commitments. In 2015, we made international climate commitments at COP21 when we had our first version of our NDCs. Now, I would agree that these commitments did not specifically mention EVs, but these commitments looked at decreasing greenhouse gas emissions in the transportation sector. And the use of electric vehicle technology certainly helps this emissions reduction significantly. So what is the aim of the regional electric vehicle strategy? So this is the aim in its exact form. I will just pick out some keywords: intelligent, modern, affordable, clean, efficient, and safe. So those are some of the keywords, or that is our goal in the REVs, to have a mobility solution that offers all those characteristics. And we're not only looking at ground transportation. The aim of the REV is to look at the electrification of surface transportation. And what we mean by surface transportation is we are also looking at indigenous maritime transport. So a lot of the countries in the region are multi-island or twin island states. So we have St. Kitts and Nevis, Trinidad and Tobago, Antigua and Barbuda, Grenada and the Grenadines. And the maritime distance between these islands is normally a short one. And the use of electric ferries is something that will be investigated or will be considered in the rollout of the REV. So it's not only about ground transportation. So this is a look of, this graphic looks at explaining the structure of the REVs. So the REVs is based on what we call 3 strategic pillars: innovation, intelligence, and electrification. And to harness these 3 pillars, we are looking at initiatives on 4 sectors, or 4 areas: policy and regulation, technology and infrastructure, capacity development and awareness, finance, market development, and innovation. So how does the REVs address the major barriers the region faces when it comes to the adoption of EVs? So from our many stakeholder consultations we would have had, we would have identified certain barriers. And these barriers would include, so these barriers are the incremental costs compared to ICE vehicles, so the additional costs of an electric vehicle compared to your traditional vehicle. We have a problem with an underdeveloped or non-existent public charging infrastructure. And it is always highlighted that we don't have enough trained and certified EV auto technicians in the region. Now, these major issues and other barriers are directly addressed in the REVs. So if you look at the REVs, we look immediately into finance, marketing, and development. So we are aware of that incremental cost, and we would try to propose measures to decrease that cost regionally. We are aware of the lack of infrastructure, and technology and infrastructure is a focus. And we are aware that capacity building and awareness needs to be looked at for all these components. So thank you very much for the opportunity for this brief talk, and I hand you back over to Cornelia.
Thank you very much, Dr. Boudou, for this wonderful introduction into the regional electric vehicle strategy to familiarize our participants with where we are moving towards as a region and what the implications of this transition towards more sustainable transportation forms mean for us as a region. Based on this input, we would now like to take you on a drive and explore different aspects of electric vehicles and address a number of questions that you might have. Dear participants, if you have any questions to our presenters, also to Dr. Boudou throughout this session, please post the questions in the Q&A section, which you find below on the dashboard. We will have 4 videos, starting with a video from the CARICOM team on electric vehicle technology, followed by a video on electric mobility intelligence presented by Megapower, then a video on electric vehicle maintenance aspects by P&V Marketing, and a 4th video session on charging infrastructure presented by Exergy Energy. After each of these videos, we will have about 10 to 15 minutes for a question and answer section where the presenters will address questions that were posed in the Q&A sections, or if you are following us through the YouTube channel or Facebook Live event, you can also pose questions over there. And Dr. Boudou will kindly support me in transferring these questions into our chat box here in the Q&A function so that we can make sure that we address all the questions you might have. Also, if we have enough time in the end, we would open up a Q&A section involving all the presenters and address all the questions that you might still have with a view of all the different aspects that we had presented throughout this day. And we hope that you will enjoy very much our video presentations. As I said, we will start with a video from the CARICOM team on the electric vehicle technology. The video features our Executive Director, Dr. Gary Jackson, Mrs. Charlene Bodley, our project development and gender experts, Mrs. Penny Bowen, our communications and PR specialist, and myself. As a brief introduction to Dr. Jackson, he is, as I mentioned, the Executive Director of the Caribbean Center for Renewable Energy and Energy Efficiency, an institution that was established in 2018. He is also founder and director of Empowered Caribbean Communities and its research arm, Caribbean Energy Solution Research Institute, and founder of Electric Vehicles Limited, and has been in various leadership roles within the energy sector in the Caribbean for many, many years. He will be available to answer your questions that are posed either in the Q&A feature or right after the video presentation live when you ask your questions. So let us start with our first video.
Hey, Penny, what's going on? Is that an electric vehicle? Yeah, man. I always wondered about those. Can you show me how it works? Sure. I'm just going to do a little charge now, and then I'm going to top it up a bit. Right into your hose? You can charge it right here? Yep. So I can just open the latch. So just open. Right. So this one is a fast charge, which is direct current. to charge it maybe in half an hour. This is your AC port from household or from a public charge, and that will take a little longer to charge. And this one is the one I'm going to be using.
Okay. And this one takes how long compared to the
Well, it depends. Depends on what type of charging infrastructure you're plugging it in. So if I have 20% to be charged to just top it up, it could take 8 hours. So when I'm getting...
So like while you're sleeping?
Yeah, exactly.
So here in a Barbadian context, you have to adapt for that voltage?
No, they just take the power from the panel and the electrician just put this 220 plug here. So you plug it in here, turn on my little panel switch, and I'm good to go. And I go to bed in the morning, it's finished, take the card off, put it inside, and I'm good to go. And then I disengage, and that's it. Yeah, so at the office, we have a more advanced charger. For this particular charger, you have to have your own cable. Cables will come with the car. So you may have different cables for different cars. So you'll definitely get a cable with the car. So what you'll have to do, once you get the cable, you need to know what your charging infrastructure is like. Decide if you're going to need an adapter for that charging infrastructure in your country, right? So you have the latch here. So we open the latch, and then we can plug this in. So this particular charger, as I said, it's more sophisticated. It could charge as low as 1 to that home and go up to at least 32 amps, which gives it a little more faster rate in charging. Right, so this particular charging station comes with a cable. So this is a type 1, and this connection is a type 2. So this one is typically US or Japan market, and this one is typically European market. So nothing changes from the vehicle from a foot standpoint. But this, yes, this is a typical 12-volt battery. So this battery actually operates your auxiliary systems, your radio, your dashboard lights, your headlights. This that looks like an engine is actually a main feature of the car. What it does, it will take the power that you're charging the car with. It will have to convert that power to DC. You're taking it from an AC supply to get it into the battery. And then when it leaves the battery, it needs to become AC again to drive the motor. So a lot of the features in the car, as if it compares to an ICE, is the same. So it has a lot of good features that
I apologize. We might face a technical issue here with the showing of the video. Could we continue with the video presentation?
I'll share my screen now and just do let me know if you can see it. Can you see it?
Yes, we can see it.
Can you hear?
Can't see anything yet.
Not yet, no.
Okay, at this point, perhaps I would ask Gary to give us a little intro or introduction into the video in the meanwhile while I get this back up and running.
I've been thinking Gary could join my sales team.
Over to you, Gary.
Gary, would you mind?
Yes, I'll make an attempt. Thanks for that, John. I didn't know I had that in me. All right, so what you would have seen next it's just the driving experience of the car. The car is very quiet. I actually call it the yoga car. It's very quiet and just relaxing. Acceleration is superb. I mean, the torque on that car is phenomenal. I remember an experience I had driving a Nissan Leaf next to a RRX XTI, which is a fast car for these young men. And in a short distance, I was able to leave him behind after he maybe gotten to maybe the second or third gear. Some persons may say he wasn't a good driver, but don't underestimate an electric vehicle in terms of torque. There is features like regenerative braking. This particular Leaf that I'm driving now, the 2020, has a thing called e-pedal, which is a very nice feature. What it does, the accelerating pedal, once you come off the accelerating pedal without pressing the brake, you actually get the car braking up. And what happens when that happens, that energy goes back into the battery. So it's actually a nice feature of the car to actually make the car more efficient. When you compare EV with an internal combustion engine, an internal combustion engine may give you 25% efficiency, and EV may give you 70% efficiency. So it's far more efficient. One of the questions my colleague Cornelia had asked me is about safety. The beauty about the EV is that the battery is actually at the bottom of the car, which is in the same safe zone as the driver or the passengers. So that section of the car is very protected. The car, low center of gravity, so the handling of the car is so much better than an ICE because the engine and everything is in the front of a car, while the batteries are very weighty. So it makes handling of the car superb when cornering. I'm not telling you to drive fast. People, do not drive fast. But it can handle better. One of the things that is interesting is that, for a person to have comfort, you need to have the right personnel, training personnel to manage a car in terms of understanding that there's 400 volts going through this car. So you don't want anyone in the body to be going under the hood of the car or underneath the car to do any particular maintenance. You need trained persons to deal with that. As well as first responders. So if a car is in an accident, you really want first responders to be trained so they know at the look of the car, they can identify the car is an electric vehicle and they know how to approach a car. But bearing in mind, an internal combustion engine also have safety requirements. So it's not that the EV needs to be more safer than the ICE. All cars need to have safety requirements because the internal combustion engine has fuel and fuel is flammable. So that is also explosive. Electric vehicle has batteries. So you just need to take care of that where the maintenance is concerned. One of the features that I spoke earlier about the fast charger. So Barbados has about 2 or 3 fast chargers on island, which is great. Well, I must say for battery maintenance, it's not necessarily good to fast charge your car all the time because that heat actually degrades the battery over time. So you can do it sometimes, but not all the time. You should understand that temperatures affect the car. So they've always said in countries like ours where it's hotter, it will impact on the car. But these vehicles have gone through so much evolution in terms of technology. So they have aspects where the batteries can be cooled by forced convection with fluid flowing between the batteries. So it keeps it cool. So that is no longer a major concern for these batteries. So battery health is going to be important. And typically, a person who maintains a car can do diagnostics because the car is an electronic car. So you can plug into the car and know exactly what is happening in all parts of the car. The beauty about the fast charger, if you choose to use it, it just tops up the car very fast. So, and charging infrastructure can be anywhere. It could be at a restaurant, it could be at a supermarket. So you could just be chilling with your friends at a restaurant while the car is charging. You could just be at a supermarket doing some shopping while the car is charging. So for that reason, it's very, very convenient. And just to let you know, training is going to be very critical for personnel to understand the car so that people can have comfort to know that persons are around that can actually maintain this car. Curtis would have mentioned for servicing, It's far cheaper to service an EV. Internal combustion engine have over 2,000 parts. EV may have 3 to 4 parts. So you need less moving parts. You don't have to service a car like your internal combustion engine, maybe every 3 months, based on the number of miles you have to take it in to get it serviced, change oil, change filter, all that. That's not necessary for an EV. An EV is just far more efficient, far cleaner, and lower maintenance costs. I'll leave it there for you. So I would say EV it's reached the threshold, it has reached a tipping point, and every single manufacturer I know now is building an EV model. So we have passed that tipping point. So now it's just about how do we as a region adapt to this new technology, and how fast can we do that? Thanks.
Great. Thank you very much for that intervention. You also wanted to show a slide on the technology aspects relating to the inverter. Maybe we can take that right now before we restart the video. I heard that the technology should be ready to go again, but maybe we can take the slide first and then we move on with the video. Gary, over to you again.
Thanks for that. Yeah, thanks for that, Cornelia. So you'll have seen where I've lifted the hood of the car and we're showing you this particular part of the car that looks like an engine in your internal combustion engine. So this is a cutaway from a Nissan Leaf. So that top part of the what you will see when you open the hood, the first part is the power delivery module. So that integrates the charger, DC converter, junction box, and just below that you have the inverter that normally feeds the motor. You see the motor, so it's very compact. So you see the motor is right there, and then the motor is connected to the shaft of the car wheel. So it is a very innovative way to design the car as it relates to the features that will get the car propelled going forward. So thanks for that.
Thank you very much. And I believe we are ready to resume the video again. So let us please start from where we left off.
Hi, Rochelle. Not hearing any audio on our end. If you could just turn up your volume a little bit, and we're good to go.
All right. Sorry about that. Oh, I know. Sorry, I understand why you're not hearing it. Apologize.
Oh, I'm just going to top it up a bit.
Right into your host.
Hey, Penny, what's going on?
Is that an electric vehicle?
Yeah, man.
I always wondered about those.
Sweet.
Can you show me how it works?
Sure. I'm just going to do a little charge now, and I'm just going to top it up a bit.
Right into your host? You can charge it right here?
Yep. So I can just open the latch of the cable. You just open.
Right.
So this one is a fast charge, which is direct current. And this will charge it maybe in half an hour. This is your AC port from the household or from a public charge, and that will take a little longer to charge. And this one is the one I'm going to be using.
Okay. And this one takes how long compared to the
Well, it depends. Depends on what type of charging infrastructure you're plugging it in. So if I have 20% to be charged to just top it up, it could take 8 hours. So when I'm getting...
So like while you're sleeping?
Yeah, exactly.
So here in a Barbadian context, you have to adapt for that voltage?
No, they just take the power from the panel and the electrician just put this 220 plug here. So I plug it in here, turn on my little panel switch, and I'm good to go. And I go to bed in the morning, it's finished. take the card off, put it inside, and I'm good to go. And then I send it, and that's it. Yeah, so in the office, we have a more advanced charger. For this particular charger, you have to have your own cable. Cables will come with the car. So you may have different cables for different cars. So you'll definitely get a cable with the car. So what you'll have to do, once you get the cable, you'll need to know what your charging infrastructure is like. Decide if you're going to need an adapter for that charging infrastructure in your country. All right, so you have the latch here. So we open the latch, and then we can plug this in. So this particular charger, as I said, it's more sophisticated. It could charge as low as what is at home and go up to at least 32 amps, which gives it a little more faster rate in charging. Right, so this particular charging station comes with a cable. So this is a type 1, and this connection is a type 2. So this one is typically US or Japan market, and this one is typically European market. Right. So nothing changes for the vehicle from a good standpoint. So this, yes, this is a typical 12-volt battery. So this battery actually operates your auxiliary systems, your radio, dashboard lights, your headlights. This that looks like an engine is actually a main feature of the car. What it does, it will take the power that you're charging the car with. It will have to convert that power to DC. You're taking it from an AC supply to get it into the batteries. And then when it leaves the battery, it needs to become AC again to drive the motor. So a lot of the features in the car, as it compares on ICE, is the same. So it has a lot of good features that which we'll see when we're driving the car.
Penny and I just had a conversation about the Nissan Leaf. Can you tell me how it compares to a regular internal combustion engine car in terms of efficiency and other technical aspects?
Yeah, you know, one thing about the electric, for the Leaf, it's like a normal car, but definitely more efficient. Internal combustion engine giving you about 25%. Electric vehicle, 70%.
So acceleration is also better?
Oh, fearless.
Nice. Love it.
Excellent. And you see how quiet it is? It's I call it the yoga car. You'll notice right here, you'll see the blue.
Right.
So that's the saying that it's getting back energy into the battery.
Is that the regenerative braking?
That is the regenerative braking.
What does affect the range?
Well, you know, climate control. So if I was to turn the AC off,
right,
I'm now at 354.
Oh,
so I turn it back on, now back at 332.
Nice. Do the different driving modes affect the range as well? Or
Well,
what else?
Yes, it will affect the range over of course. You'll get enough regenerative braking driving in econo, as I'm doing now. Particularly, this particular Leaf has a feature called e-pedal.
What is that?
So it helps to brake the car and provide regenerative braking. So now I'm not pressing the brake, and the car is going to come to a complete stop.
And what affects the battery life and health?
Well, you know, depending on how you charge it, fast charging is not recommended all the time. It puts too much, it heats up the battery, and that helps to degrade the battery. So obviously, you know, temperature is what affects the battery degradation. So they've always said, depending on we're in a hot climate versus a colder climate, you know, there can be differences between the two type of climatic conditions. We're actually sitting on the battery now, so the battery is actually at the ground of the vehicle. Having the battery at the base of the car is actually a perfect idea.
So we have a lower center of gravity?
Exactly. So, you know, it handles better.
Because there are also a number of concerns about electric vehicles and safety if an accident happens or something.
So the thing about safety is that, you know, we need proper persons to operate that will manage the car, maintaining the car. The car has about 400 volts going through it, so it's an electric vehicle. So there are particular normal electrical safety requirements. You need the right technicians to actually maintain the car. If the car is in an accident, you know, we need to have your first responders trained. The guys will need to be trained to know that this is an electric vehicle, how do they approach the car, what type of equipment they will need. As a matter of fact, all cars need to have safety features because an internal combustion engine has fuel, and fuel is flammable. An electric vehicle has a battery. Both type of vehicles will need safety requirements. It's just that we need to have the right training for each of the type of vehicles. So there's no worry around the technology of each of the vehicles in that regard. Hey, what's going on? We have a charger at the office. How come you're charging here? Well, the slightly top up is an ultra charger that can charge the car faster. So it can charge it from maybe 80% in 30 minutes. You have to pay for these services. So it doesn't come free. So there's no checking for the car and ensuring that the card has been accepted. And then it's asking me which one to choose. I choose the one that is compatible with the car. And look, it's now charging. Do I have patience for this? I mean, what happens if I have an EV and it runs out of charge? This car can give up to 380 kilometers. It's the size of Barbados. I know you can get home with 380 kilometers. So you can get home and you go around the island if you want to. In St. where I'm from, quite a hilly island. Isn't there a difference? Like, can I go around the island of St. Lucia? As a matter of fact, yeah, when you go up the hills, you're going to take a lot more to the battery. When you're coming down the hills, you can actually have regenerative braking. So you actually have power going back into the battery. You can plan your drive in a particular way, and you'll be fine. I mean, even for bigger islands like Jamaica, an EV is still appropriate. What about maintenance? Because, you know, used to having an ICE vehicle, with my regular checks, the mechanics are quite attuned to my vehicle, but in terms of maintenance, is it more costly? Does it require more from me as the owner of an EV to maintain the vehicle? Well, it's actually less maintenance for you. I mean, there are less moving parts in an electric vehicle. In an internal combustion engine vehicle, you have maybe over 2,000 moving parts. In an EV, maybe 3 or so. So when you have to go through this quarterly or 3-month maintenance program with your internal combustion engine, you need far less. What I can say, which I was sharing with Cornelia recently, is that you need people to be trained into electric mobility so you will have the comfort that once you leave it with your mechanic and you're trained and certified EV maintenance personnel, then you know it's in good hands. I must say I'm swayed. I am convinced. Excellent. Love it.
So that was our first video presentation with an overview of electric vehicle technology, driving experience, and all aspects electric vehicle from the CCRE team. Since we have lost a little bit of time due to our technical issues, we would jump straight into our second video and then have a joint question and answer session for both Dr. Jackson and Joanna Edgehill from Megapower after the second video. So our second video presentation will present to you the electric mobility intelligence aspects by introducing the MG-ZS electric SUV, shown by Mrs. Jo Edgehill, co-founder and director of Megapower Limited, and Sharon Waits, operations manager also at Megapower Limited. We will go on with the second video now.
I'm Jo Edgehill, co-founder and director at Megapower Limited, the Caribbean's leading specialist electric vehicle garage. Today, we're going to be talking about our latest product, the MG-ZS 100% electric SUV. 44.5 kilowatt-hour liquid-cooled lithium-ion battery pack powers the MG, giving range in excess of 250 kilometers per charge. That's about 2 laps at least round Barbados. Also, the technology, being liquid-cooled, the battery pack is ideal for our humid and hot temperature here in Barbados. What we're seeing with the MG is we're seeing a much larger battery pack than the vehicles that we first would have brought in than with the Nissan Leaf. So originally the Nissan Leaf was a 24 kilowatt hour battery pack. Nissan does now make a 62 kilowatt hour battery pack, and that's the way I guess the manufacturers have all moved with the technology into bigger energy density and larger battery packs, giving more drive range for the customer. The vehicle charges from the front, the flap opens up, you plug in, you lock the vehicle, and the charge instantly engages. The MG ZS comes with an overnight charger, meaning that the vehicle will charge to full in 6 hours. When charging the MG, there are LED lights that light up the MG symbol, and it's glitzy. There's keyless entry, meaning that the keys can be in your pocket, in your bag, briefcase, handbag, or simply in your hand. 17-inch alloy wheels on the MG, along with windmill-style rims, in keeping with the renewable energy theme.
This is the MG ZS electric vehicle, 44.5 kilowatt liquid cool lithium-ion battery. I will take you inside and demonstrate some of the features that it has. So to start the vehicle, it's push start. So you put your foot on the brake and you press the start button, and the vehicle has been engaged to start. To put it in drive, you turn the toggle to the right. To put it in neutral, you turn it to the left once, and then you turn it to the left again for reverse. And then it comes up to show you the reversing camera.
There are 3 silver buttons. The first one is the driving mode, so you can drive in eco, normal, or sport. The second is the level of regenerative braking, 1, 2, and 3, with 1 being the slightest level of regeneration and 3 being the heaviest. The most economical way to drive the car would be in eco mode, and 3 in terms of regenerative braking. The third toggle is the battery. So on your dash, you have an E to F, kind of traditional empty to full markings, and there are light dashes below them. As you head towards the E, you can push up on the battery button and it will tell you more or less your range until you need to recharge.
Currently I'm pressing the battery mode, and it shows you that you have range to empty 214 kilometers with AC on. When we turn off the AC, you will get more mileage, and it shows you 238 kilometers left to empty. In eco mode, at the state of charge it is at currently, you will have 262 kilometers left to empty. In sports mode, you'll use the most power, and it would show that you have 226 kilometers to empty. So when I press the curse, currently it's at regenerative level 3. I press it down once, it shows you moderate regeneration level. And I press it down again, it shows you the least regenerative level, meaning you'll be putting the least amount of power back into the battery while you are driving.
The MG ZS comes with Apple CarPlay and Android Auto, meaning that I can plug into Zoom, I can plug into my audiobooks, my maps come up on the screen, WhatsApp messaging. You can take calls by voice command note on the steering wheel.
The dash is currently showing the radio function. If you want your music to focus on the passenger side alone, it allows you to do that. So for the trunk space, there are 2 levels. This one being the lower level. That's being the higher level. Underneath here, you can also store your charging leads. So here it is your charging lead for public network usage. It also comes with a puncture repair and a spare tire pressure function, so that you will not necessarily need to go to the gas station to have air into your tire. And then this charging lead here, it's a UK 220 plug that you can have installed at your home as well.
We've rolled out a charging network at more than 35 locations across Barbados, and we will continue to put more chargers on that network. Vehicles such as the MG ZS, along with the Nissan Leaf, BMW i3, and other modern electric vehicles can all plug into this network. What we've seen is incredible progress, incredible research and development and technological advancement since we started Megapower. So we've seen greater energy density, larger battery packs, more range for the driver. There's now over 500 electric vehicles on the road in Barbados, from cars to vans to SUVs to buses. And we're seeing great interest now across the region. This shows that the Caribbean region is now ready for electric vehicle uptake. We are ready to drive change.
These two videos now presented a good overview of the technology aspects of electric vehicles, the intelligence that can be derived by the drivers and owners of electric vehicles. And we would like to take this experience and jump into our question and answer session, actually integrating all three presenters from the first part of this virtual event. We had a number of questions already in the Q&A section. So I would like to start with one question that was posed to Dr. Boudou on the regional electric vehicle strategy. That's a question from Mr. Alan Nadur. Are we looking at partnering with any of the multinationals? I know they are very advanced with their technology infrastructure and are looking at investing in emerging markets. Dr. Boudou, could you speak a little bit about this aspect?
Yeah, sure. Thank you, Colin, and thank you for the question. Whereas the electric vehicle, the regional electric vehicle strategy is currently under development, and we do expect the comprehensive document to be completed probably the first half of next year. I believe those recommendations would also come out of the document. And your point is a good one, and it will be looked at. I mean, the team that is developing the document will consider these points as well. Thank you.
Thank you very much for that intervention. Our next question addresses the technical aspects, and we actually have two questions from Dr. Keith Nichols. First one would be, how would mountainous terrains affect the performance and range, since we have a lot of these mountainous areas in several member states? And the second question would be, if charging is done from home, how does that reduce total carbon dioxide emissions if the same fuel source is used for generating household power? And I would refer that question first to Dr. Jackson, and Joanna, if you want to add to that, please feel free.
All right, thanks, Cornelia. Thanks, Keith, for your questions. I'll take the first one first. All right, so as I mentioned before, yes, you will have, when you're going up hills, you will lose some energy from the battery, similar to an internal combustion engine. You're going up, you're going to be using more fuel. The beauty about the EV is that when you're coming down the hill, you can actually do regenerative braking. And you can get back power into or energy into the battery. For internal combustion engine, you're not going to get back any power, you're still going to be using fuel. So efficiency-wise, as I said, the internal combustion engine is at 25%. EV can give you 70% efficiency. So it's still ahead of the curve within the Caribbean as well in terms of those mountainous countries. As I said, even for a country like Jamaica that has large mountains, you're still ahead of the curve. As it relates to charging at home, say you have no solar system at home, no green energy, you're getting directly from the grid that is burning HFO or natural gas, whatever, diesel. Those power plants can run at 35% efficiency at most, right? And you remember your internal combustion engine for cars running at about 25%. So you have more efficiency at the power plant. So even after I make that power and transmit it to you, I'm still ahead of the curve driving an EV powering from the grid. I'm still going to be saving money. As a matter of fact, I did a calculation a couple of years back, and I was saving, when I use the grid price, not my solar system, just a full grid price, at about 30 cents per kilowatt hour. I was still ahead of the curve. I was saving 30% of my cost if I was to have an internal combustion engine. Thanks.
Thank you very much, Joe. I'm sure there would be some interesting views also from Mega Power.
I mean, honestly, Dr. Jackson is answering these questions as I would. I think an important thing to remember is also the size of our islands. So even Jamaica is not that big, you know, not when you compare to North America, to Japan, to Europe, where these vehicles are manufactured, where they're, you know, initially designed for. So even, you know, with his Nissan Leaf, you can easily get across Jamaica up and down. I have, up to last month, I was fortunate to be able to go to Dominica, and I drove a Nissan Leaf there. And again, Dominica is very mountainous and, you know, no challenges. One of the things as well is with the downhill and the regenerative braking, you're putting a lot less pressure on your brake pads. So that's one aspect to the vehicle, one part that you really do not have to replace. With the regenerative braking, it really protects those brake pads.
Okay, great. Thank you. We had a direct question for you, Joe. How many vehicles has Mega Power sold this year, and how does it compare over the last 3 years? So the question is directed, how much growth do you actually see?
This year, we've stayed flat on last year. So we sell in our local market of Barbados 6 to 8 vehicles a month. Our international sales are down compared with last year. This month, though, we did send 2 vehicles to Trinidad and 2 vehicles as well to Antigua, where we have a permanent office. So I'm hopeful that maybe that's a sign of more demand. We've had more interest recently outside of Barbados, but none that I can say are definite sales and leads going into next year. But what we've done this year that has enabled us to stay flat, because otherwise for sure we'd be down, is that we've introduced this new MG ZS 100% electric SUV. So I think there are a lot of people that liked the idea of electric, but the Nissan Leaf as a car wasn't cutting it for them. You know, we have a large SUV culture here. And so by introducing that vehicle, we've managed to maintain sales as per last year. And I can see next year, hopefully, but there's a lot of uncertainty, being a good growth year for us. Where we've had growth, as Delisle will know, is on the introduction of the electric buses. So with 33 on the road already with the Transport Board in Barbados, and another 2 arriving next month, taking it to 35 by year end. That's obviously completely new for Barbados and a new revenue stream for Mega Power as well.
All right, thank you very much. We have another question asked by Simon Fraser of if there are any examples of solar installations paired with battery electric vehicles in a residential environment, and which solar capacity would be required to charge a car if you look at examples like Leaf or Ionic.
Yes, we have customers that have solar PV systems at their homes that are then linked to their electric vehicle charger, for sure. And I have in my own home and at the office as well. Mega Power has several commercial applications that support our charging network and our vision of promoting the uptake of electric vehicles powered by renewable sources. I'd say a 2 kilowatt system is great for if you want to power one vehicle. And, you know, how I see solar is put on as much as you can afford to, and as much as you need as well for your demand.
All right, thank you very much. We have 2 technical questions I see here in the chat. One would be to speak to the longevity of the battery in relation to charging frequency and age of the electric vehicle. And the other one is more open, but relating to safety aspects, so road safety. With vehicles being very silent, pedestrians may be conditioned to listen for regular internal combustion engine noises, but not to electric vehicles. How can we address this? This is a question both to Joe and other presenters.
Sorry,
Dr.
I'm
Jackson.
reading through the questions at the same time as listening to you, and I'm a little lost as to which one to answer. Gary, do you want to take that and I come back to it?
Sure. All right. So as it relates to the sound from the car, I mean, most modern cars now are very quiet. You know, even for an internal combustion. If you were to buy some of those high-end vehicles, I mean, they try to make the cars less noisy, because in urban development, that is something that the Society of Automotive Engineers are cognizant of, and they try to make the cars even quieter. They don't want loud vehicles because it's actually a nuisance in areas where you have hospitals and so on. You know, people are putting features in the cars to give it a little sound as an add-on. You know, you couldn't allow your car to sound like a Formula One car if you want, but to let you know that the driver is responsible for the car, and a pedestrian would need to be also responsible for walking across the road. So a driver should be looking. I could tell you my driving experience is this: when I'm coming out of a carport and I see people around, I would typically toot my horn. In some areas, the car has an audible, in particular in reversing. So it gives us an audible so persons know you're moving. So there are features that the car can have that could provide that additional safety in that regard. Was there something else that was asked, Cornelia? I just want to also add to the statement, Joanna's, about the solar system on your electric vehicle. Again, you remember your electric vehicle is a function of how much charge it needs. All right, so if you're going right down to zero and you have a 62 kilowatt hour battery and you want to charge that back up to 100%, that's going to be a challenge for a house system, because that's 62 kilowatt hours of energy that you're going to need. And as I mentioned earlier, it's about planning. So you would normally size a system in accordance of what you consider a particular drive pattern. So you may want to consider 20% of the capacity based on your normal route of driving, or 30% capacity, or 10% capacity of your battery, depending on the range that you want. So it's similar to sizing a system for your house. You will not size just your system for the house. You will size it in order to meet your demand side aspect. So you want to be efficient before you actually implement or install a solar PV. So it's just like a car. You want to drive efficiently, and the car calls for more actions on your part. As you realize in Joanna's presentation, you see a lot of features. The car has all its intelligence. So it gives you a lot of information to make informed decisions, which is a beautiful aspect of the car. You see the charging rates, you see how much is depleting from the battery. You can make decisions of the regenerative braking, the levels of regenerative braking you want, so that you can get more out of the battery. So, you know, it's all about planning, and it's all about adapting to this new technology and the way forward. Just like your phone. You know, you have features of the phone that you use, and there's some features of the phone that you don't use. But if you were to use all the features, you could actually have an enhanced experience using that phone, similar to your car.
Thank you very much for that. We have 2 questions which address an important issue for the whole region. One was asked for Barbados and the other one for the region. But with the transition to electric mobility, we will first of all have to get rid of or retire internal combustion engine vehicles that are existing on islands, and we will have also an influx of batteries that will at some point also need recycling or any other second life application or reuse, disposal, etc. plan for that. How do we approach these two aspects? Who wants to take that question?
Okay, may I jump in here? Yeah. Okay. Well, it would have to be a slow transition. We won't have to necessarily retire internal combustion engine, but it would have to be a gradual process of phasing out internal combustion engine, and with government policies, right, and tax exemption because of the cost of electric vehicles. It will have to be a partnership between government and citizens, where we can then transition from internal combustion engine to electric vehicles. And also we have to take into consideration that all the manufacturers, this is the way they are going. And just about 2 days ago, the UK has made a statement clearly stating that they will only be selling electric vehicles by 2030, not even hybrid vehicles. So, you know, the government of the regions have to move speedily to collaborate with the citizens on this issue.
Yeah, I can add to that. And I think this is an important point. There was also a question in here about Trinidad, and what we have in Barbados is solid partnerships and a solid unified approach. So we have a government that is speaking to electric transport. We have an electric utility that is speaking to electric transport. We have private sector, we have agencies. And so, you know, if you don't have that, in the case of Trinidad, where that is just not there, then EV uptake is going to be very difficult. But also it's great to have kind of a big vision piece of, okay, this is what we're going to do by the year 2030, and get overwhelmed and think about, oh gosh, well, how are we going to retire these vehicles and all of that? Or you could look at it in 2-year increments. You know, what are we doing by 2023? What are we doing by 2025? And really move in an action plan to achieve goals and achieve targets. It's what we do in our business at Megapower. And I see also, you know, we have these amazing partners here in Barbados that share that vision. And it has to come from the government. It really does, for electric vehicle uptake to be possible across the region.
All right. I just wanted to add, all right, so like any system, it's on a holistic approach. And the governments have to recognize, and I say the governments, I don't mean just the political directorate, I mean the people as well, have to recognize the transition, right? Now, what is important is that we are living in a global village, and internal combustion engines that are being, you know, obsolete, or countries who are moving, like the major countries like the UK or Europe who are moving away from ICE, you'll have a market for those vehicles. So don't get me wrong, there is going to be a market for those vehicles. What is going to be important for our region is if we are going to be one of those receivers of that market, because we don't want to be in a situation, and this is where we have to make very clear decisions going forward. These vehicles will come cheaper. And as you know, we have a lot of vehicles in the Caribbean, so people are going to want to import these vehicles if they are coming cheaper. No, they are going to be a stockpile for us, and maybe, and I'm going to be maybe a little harsh, a dump site for us. So we have to be very mindful of that. Now, within the e-mobility transition, there are going to be a number of technologies that are evolving. You'll have heard about fuel cells. You've heard about the batteries. People are already talking about how do you dispose of batteries. In the same sense, how do you dispose of fuel, oil that is coming through internal combustion engines? And this is why I'm saying we have to have a very holistic approach in how we are going to be structuring, disposal, introduction of new technology. Now with the hydrogen economy that is coming on board, fuel cell electric vehicle is also going to be a game changer. Batteries, lithium ion is still going to play a significant role. You see it in your power tools, you see it in your phones, you see it in computers. What the region will need to do is identify these areas of interest, identify these clear areas of interventions with technology. And we are part of the technology evolution as well. We don't have to receive, we can be part of the solution. So we don't have to be only on the demand side. We can be on the supply side. We can put innovation into the diversification that we so seek to get the best structure and best output for the region, because we are small and we can't be taking all of this in our countries and become a dump site. So I just want us to know that the REVS is coming on board. So the REVS is going to be helping, which is the regional electric vehicle strategy, is going to be helping us to, and we're taking information from multilaterals as well, because a lot of people are working in EVs, but there is a local, a regional context that obtains that we have to ensure that we protect the citizenry in the region where this is concerned. Thanks.
And Gary, I just want to add one thing to what you just said also, this is what we have to, why I think it is important that we should have some integration and some inter-island discussion with these sort of situations, because unlike, I don't know what is the policy for the other islands, but in Trinidad, we have a policy where, we as individuals, not even franchise dealers, we have started this business of the hybrid and the EV, but we are always being shook down by the government because we are not a conglomerate or we are not a franchise dealer as such. And we are doing our part, but we are not really receiving any support from the government. It is currently they have taken a backward step. So and with the backward step they have taken now, it is going to make things where non-hybrid vehicle is going to become less expensive than a hybrid or electric vehicle. So again, it's going to drive people away from this. So we could have discussion into how policies work with different countries.
Thank you very much for that addition. I totally agree that regional coordination and cooperation and moving together towards electric mobility will be the key to our future. I see a lot of questions still in the Q&A section. We have to move on with our video presentations now. I would ask the presenters that have presented already to still answer questions in the chat, but to leave any questions that relate to electric vehicle maintenance or probably charging infrastructure to our other two presenters, which will then also have the opportunity to reply to those questions after the video presentations. I will hand over at this point to Nadia Mohamed, who is Project Officer for Energy at the CARICOM Secretariat, who will introduce our next video presentations and presenters to you.
Thanks, Cornelia. So for our next presentation, we're focusing on servicing and maintenance. And in our first video, Gary and Charlene touched on servicing, and he explained that it's less maintenance because there are less moving parts. So if you drive an internal combustion engine car and you have your service file, now would be a good time to take it out for comparison, because our next presenter will take you through a step-by-step checklist of maintaining a Nissan Leaf. So Mr. Visham Bawa has been in the automotive business for 36 years, and he started his own business at the age of 20 in 1984, wholesaling spare parts and accessories. In 2010, he became the president of the Trinidad and Tobago Automotive Dealers Association, where he started lobbying for tax exemption on hybrid and electric vehicles. From 2012, his company, PNV Marketing, was the first company to import hybrid and electric vehicles into Trinidad and Tobago, with a full complement of trained staff to service and repair these vehicles. And also noteworthy, in 2016, his service technicians actually started training on service and maintenance of hydrogen fuel cell vehicles. So I hand over to Rochelle now to take us into our third presentation, which focuses on maintenance.
Hello everyone, I am Visham Babwa, CEO of P&V Marketing Company Limited of number 11 Mulchan Road, Chaguanas, Trinidad, as well as President of Trinidad and Tobago Automotive Dealers Association, TADA. I have been in the automotive business for 36 years and have been the President of TADA for the past 10 years. P&V Marketing has been the first and only company to import, service and maintain hybrid vehicles from 2012, the full electric vehicle from 2015 and the e-power vehicle from 2016. Since I have pioneered the transition from non-hybrid vehicles to hybrid and electric vehicles in Trinidad and Tobago, I have composed a video to demonstrate to you how an electric vehicle is serviced and what has to be done with relation to this vehicle. In this case, we are going to use a Nissan Leaf. In the electric car, you would have gauges that would indicate to you the amount of battery life that you have remained in the vehicle and the amount of kilometers that you will get with that amount of battery life. For example, in this one we have a 77% battery life available, and this will give you up to 178 kilometers drive. Now again, this is dependent on the condition and your style of driving. Heavy acceleration will use more electric power, so that amount of kilometers would be reduced, as well as if you do light acceleration, you will get the 178 kilometers. This vehicle also is equipped with what you call e-pedal. So with an e-pedal, you don't have to use the brake. I shall demonstrate this to you now. You're using the e-pedal, so I'm mashing only the accelerator pedal here, and once you release the pedal, the vehicle will come to a stop. It slows down for itself and it comes to a stop. Right, so we are now going to talk about the service and what is required to maintain an electric vehicle. For example, this is a Leaf that we have spoken about, and we are going to show you what you need to check and at what intervals you need to check it. We have a 12-point check here. This is the manufacturer's specification, so we don't want to move away from this because we have to move with what the manufacturer specifications are. First on the list is to inspect the 12-volt battery to check the connections, the cables, check the voltage and everything with the 12-volt battery. The second thing we are going to check is the brake fluid. We are going to make sure that the brake fluid level and check the color of the brake fluid. That would indicate to you if the brake fluid needs changing. So you check the brake fluid and you make sure it is the optimum level and the color is good. The third is the coolant. Now these vehicles don't really require coolant to cool the battery or the engine as such. The coolant is there just to cool the motor, which does not generate too much heat. But you must check the coolant to make sure that is up to maximum level. Fourth would be the windscreen wash. This is very important because of the conditions of the road. You need to check your windscreen washer to make sure the water again is up to optimum level. The charging ports, which is extremely important, you need to check the charging ports to make sure that there are no gunks, no buildup of dust, there are no cracks or no holes or any way that water would seep into this, because this is the charging port for the vehicle. You have two charging ports here. You have a level 1 and a level 2. Most people use the level 1 to get a trickle charge. If you have a type 2 charger, then you would be using the type 2. So you make sure that these ports are cleaned at all times. We shall move on to number 6 on the list, which is the inspection of the wiper blades. You inspect and change if necessary. In Trinidad, people take rather long to change your wiper blades. This should be something done maybe every 6 or 8 months. In cold countries, they do it twice a year, but in Trinidad, it could be done every 8 months. We move on to number 7 now. So we are going to check caliper and brake pad. You're going to take the brake pad out, have the caliper cleaned, have the brake pad cleaned. You're also going to grease the pins, make sure the shim and everything is clean, so the brakes would be working to an optimum level. Then you will have to move on to where you have to check the boots, the drive shaft boots, and all the boots, the suspension, all the links, axle, and everything that operates the suspension. You check the strut to see if there's any leak or anything abnormal with it, that you'll have to have it done. Although it's a electric car, it still has a conventional suspension. So you must have the suspension checked at regular intervals. We shall make sure and check the drive shaft or the axle, as they would call it. The boots, make sure the boots are not leaking, it's not damaged, and check the other links. Also you can check the ball joints and everything under the vehicle again. Then you can check for the reduction oil. If you have to drain the oil, this is the drain plug and this is the fill plug. It does not require changing this oil regular. This would last very, very long. So, but you just inspect it to make sure there are no leaks or anything that will damage the reduction gear in the system there. When you're finished there, then you'll check all the wirings. Of course, you know, all the wires that has a salmon cable in it is a live cable. So this is the main cable that goes into the battery. The battery is located to the bottom of the car here. And you'll have to make sure that these connections are not slack or they are not corroded in any way, just to make sure that the vehicle will operate to optimum level. Another part of the inspection, whenever you go to have your car inspected, you have to make sure and have the lights inspected, make sure the bulbs are working, the lens are not damaged, they are cleaned and in proper working condition. When you are maintaining and servicing an electric vehicle, you must have the proper equipment to deal with this vehicle, because this is a high voltage vehicle. So you could be electrocuted and it could even be fatal. So bear in mind that anybody cannot interfere with these vehicles. You must be trained, and to be able to repair this vehicle, you must have some knowledge of electrical works and mechanical works. And with that in mind, I shall say that, you know, when people hear about a hybrid or electric vehicle, they get scared. Some people get excited. But with this vehicle, the savings are great because they don't have a combustion engine. And with the absence of a combustion engine, you don't have a lot of the parts. You don't have oil filters, belts, you have no fuel tank, you have no fuel lines, you have no fuel pump. You don't have all these set of mechanical parts to repair. You don't have hoses, you don't have the lines, all these things, you don't have it. So the savings that you will get from these vehicles would be phenomenal. because you don't have to go to a gas station and put liquid fuel. So you'll only be using electricity, which you could charge from your home, or if there are charging points, if you have a grid, you could also charge from the grid. So you know, the savings that we are telling you about with an electric car is great. More than 80 or 90% compared to a conventional gasoline engine vehicle. You know, so we are trying to promote this and to get this around the Caribbean region and in Trinidad, and we would like people to gravitate towards it because it is the way we have to go. It is the environmental issues, it is the health issues we are talking about, and it is the issues of finances, personal finances. Right now, persons are going through a very difficult time, and if you are really looking to save money, I think this is the way that you should go.
Thank you, Mr. Barber. So some takeaways from your presentation are that EVs are easier to maintain, much easier to maintain than ICE vehicles. There are some maintenance procedures that you have to do whether you own an ICE vehicle or an EV. The tires, for instance, are one of the common denominators. And thirdly, it requires trained mechanics and automotive electricians who are able to diagnose and repair EV systems and their components. So at this point, I would like to take the opportunity to highlight one of the training programs that the CCRI has developed. It's called Training of Trainers program on electric vehicle technology, safety, servicing, and standards, and it will be held in 4 modules. So I would briefly ask, I'd ask Cornelia or Gary to give an overview and just let us know what the modules are about and who can participate.
I just ask Cornelia to just go through that. So as you mentioned, Nadia, yeah, we'll be having a trainers. It's happening both synchronously and asynchronously. So it has already started. So persons are able to, would have been registered, would have been able to now go in and start this course through the period. So Cornelia, if you could just highlight the modules that are going to happen over the course of the next month.
Sure. Thanks a lot for the floor again. As Nadia had outlined, we have this electric vehicle training of trainers program, which has already gone live this week on the 18th. It is a training program that is offered mostly in an asynchronous format. So there are pre-recorded sessions together with some interactive activities and a script for our participants. So our participants can complete the modules on their own time and whichever way fits best to their schedules. Our main focal groups for this training program are instructors at technical institutes, at established training institutions across the CARICOM region, automotive mechanics acting as multipliers, so mechanics that would train other people in their department and act as trainers to distribute the knowledge about the technology aspects. We also have as our target groups first responders and regulators ranging from people from ministries, customs, and other departments, regulators that would address certain aspects of electric vehicles. So the modules, to get into that, would cover as a module 1, which is the most comprehensive one, electric vehicle technology, where we really go into depth of looking at electric vehicles, battery electric vehicles, plug-in hybrid electric vehicles, and passive hybrid electric vehicles. How does the technology work? And this module is split into a fundamentals session, which is only asynchronous. So as I mentioned, participants can go online and complete the module within their own time frame. And we have 2 live sessions for an advanced module 1 to go more in depth and demonstrating the different relevant technology aspects to the participants. In module 2, we move towards servicing and maintenance. So that would be a deeper look into the aspects mentioned by Mr. Babua in his video. In module 3, we will look into the safety aspects of electric and hybrid electric vehicles, which would be especially imminent for first responders when they come to an incident with an electric or hybrid electric vehicle. How do you respond to that situation safely? How do you disable high voltage components in the car? And how do you manage the whole situation in the best possible way? And our module 4 would address issues of standards, regulation, and testing. So that is a more of a broader view on the other technology aspects in the module. As I said, we had already started with that program. It is running from the 18th of November and should be finished by the 13th of December. So participants can log on to the program on their own schedule, apart from those live sessions, which will happen on the 1st and on the 3rd of December, both from 10:30 to 12:30. If I may mention here, and then all modules should be completed by the 13th of December, and participants get a certificate of completion for each of the modules that they are participating in, and hopefully successfully completing all those modules. We had a great interest in this training program from the region, so we have limited spaces available. This training program is also implemented with the technical support from Fanshawe Global, which is a college in Canada, who are offering their expertise and also their learning management system. So that is the platform that is for this program used for participants to log on and complete their assignments. And we will also have this training program available in the future through the CCRI platform, and of course I hope to offer further training programs for all of you, because we could not accommodate for all the people who were interested in the training program. But as I said, we look forward to offering this and further trainings in the future. Thank you very much.
But for this program that you have running, do you have any available space as it is now?
We had to prioritize our participants to accommodate for all the target groups that we really wanted to reach with the different modules and overall. So we, at this point in time, we usually don't accept any more applications, because we already unfortunately had to reject a few participants out of capacity reasons.
Thank you.
Thank you, Cornelia, but you did mention that it will be available in the future for other participants, so we look out for more promotion on that. So right now, I'll move on to the next session. This presentation features Xavier Gordon, and he will be discussing charging infrastructure. Now, each of the presentations would have touched on how to charge an electric vehicle, but Xavier will dive deeper into the topic. Xavier Gordon is the owner and president of Exergy Energy, a clean energy development firm based in Toronto, Canada, and they specialize in solar PV, energy storage, and electric transportation. In the Caribbean in particular, he has led several projects to the region concentrating on fleet electrification for public transit, government fleets, and private fleets. And Xavier and his team are currently developing a national electric vehicle charging network in Jamaica for deployment in 2021. And the first station will be open by year end. So Xavier's video has been filmed in Canada, where there are a wide variety of types of chargers and infrastructure, which impact the speed of charging and how far you can drive. So let's hear his explanation in the video next. Rochelle, over to you.
My name is Xavier Gordon, and I'm the president of Exergy Energy. We are an energy transition solutions company based in Toronto, Ontario, Canada, with a regional office in Kingston, Jamaica. The goal of this video is to help the audience understand how battery electric vehicles, EVs, are recharged. We will make comparisons to internal combustion engine vehicles and illustrate the most common ways to recharge an EV. Individual markets may vary slightly, especially when it comes to plug standards. Let's first start by recapping the fueling experience for an internal combustion engine. First, you drive to the gas station, where you pump a certain volume of fuel into your vehicle's tank and pay for the transaction based on a cost per unit of volume, dollar per liter or dollar per gallon. It's usually done in under 5 minutes. Then, you use your vehicle until you approach a lower limit of fuel. At that point, you then drive back to the gas station. Stations are usually located along major roadways served by numerous vendors in a competitive market. Prices may vary daily depending on the retailer and the fuel class being purchased, whether it's regular, premium, or diesel. So let's look at an example of fueling a vehicle in Jamaica. A 2020 BMW 5 Series has a tank size of 68 liters, an estimated fuel economy of 9.5 liters per 100 kilometers. The gas price of fuel in Jamaica for regular in November 2020 is about $132.74. Therefore, that works out to be a cost per kilometer of $12.50. Now, let's look at the recharging process for an electric vehicle. 1. You park it. 2. You plug it in. 3. You walk away. 4. You plug it out. And 5. You drive away. So to compare, EVs are charged using electricity, with their metric being kilowatt hours, just like it would be for your home or business. Recharging can take place anywhere where you have permission to access electricity. The learning part when it comes to EV charging is really the recharge time. Before we get into questions about that process, let's look at the cost to charge a comparable EV to the BMW 5 Series that we talked about earlier. A Tesla Model 3 Standard Range Plus has a battery size of around 50 kilowatt hours. Think of the battery size as something equivalent to that of the tank, how much energy that vehicle stores. That battery, from full to empty, will get you around 450 kilometers of range. The cost of residential electricity in Jamaica at the time of this recording is around $38.60 per kilowatt hour. That means to fully recharge your car, you would need around 1,930 Jamaican dollars. That is $4.30 per kilometer, or roughly 1/3 the cost of a BMW. We can conclude that having the charger in the right spot at the right time can result in the massive energy cost savings that are attributed to an EV. Now that seems simple enough, but for a regular driver, it leaves a lot of questions. The first question is, will my parking space allow me to plug it in? It is likely that your parking spot is close to a source of electricity. This means you can plug into the closest outlet, assuming you have permission to do so, or you can plug into an electric vehicle charging station that has already been connected to that electricity source. Having the right connection where you park will significantly increase the convenience of recharging your EV. So let's say you have sorted out having power close to a parking spot. How long do you have to be there? It depends on the car, and it depends on the equipment that is recharging the car. To go from empty to full can vary, from 40 hours to 30 minutes. But remember, most vehicles are parked 90% of the time. The concept of charging while you park is called opportunity charging. Instead of going from empty to full with long durations in between, the EV driver will recharge in small increments. When charging is done from home, this almost always results in leaving home in the morning with a fully charged vehicle. A modern EV in 2020 is usually capable of 250 to 500 kilometers of range. Given these distances, most drivers may only need to plug in once a week. Let's talk about the 3 levels of EV charging and how we can calculate recharge times. Level 1 is usually called portable charging because you'll use a portable cord that comes with your EV and plug it into any standard outlet. This is the slowest way to recharge an EV. Level 2 is usually called fast charging. It can be done by a heavy-duty portable cord, or more commonly, using a fast charging station. It will connect to the grid by way of a higher voltage and higher current circuit installed specifically for its use. This circuit is comparable to that of an electric clothes drying machine. Level 3 is usually referred to as rapid charging. These are heavy-duty charging stations that operate using DC power rather than the AC power that is found on level 1 and level 2 charging infrastructure. They will connect to commercial grade voltage and current circuits that require in-depth installation and experience. These chargers are usually found near highways, busy central districts, airports, and major destinations. Now, recharging depends on both the EV charger as well as the EV itself. Think of the EV as being able to pull power and the charger as being able to push. When an EV is first plugged into a charger, the 2 devices will communicate with one another to see which of the 2 is the slowest and then agree to charge at that rate. The recharge rate is usually specified in kilowatts of power. The amount of time needed to recharge a battery will be a function of both that power rating and how much energy the battery needs to be full. One thing to note is that most new EVs will be able to accept level 2 and level 3 charging at different rates. Let's look at an example. Let's assume your vehicle has a 56 kilowatt hour battery and can accept 11 kilowatts at level 2 and 200 kilowatts at level 3. Let's also assume you have a level 1 charger that can push 2 kilowatts of power, a level 2 charger that can push 8 kilowatts, and a level 3 charger that can push 150 kilowatts. In each of these 3 cases, the charger, not the vehicle, has the lower limit, and therefore we would use those figures to calculate the recharge times. So for a level 1 charger pushing 2 kilowatts, it would take 27 hours to recharge the battery. For a level 2 charger at 8 kilowatts, it would take 7 hours to recharge the battery. And for a level 3 charger pushing 150 kilowatts, it would take 23 minutes to recharge the battery. In addition to EV charging speeds, there are also different plug types, similar to electricity outlets. Just like outlets, different plug types are associated with different countries of origin. In the Caribbean, being a primarily right-hand drive market, most new EVs will either have a European or Japanese plug standard. Okay, after looking at those numbers and plug types, let's go take a look at EV charging in action. Let's start by looking at a level 1 portable EV charger. This mobile connector came with my EV and can be plugged into any standard outlet. Here it is in my garage, with one end in the outlet and the other end plugged into my EV. Let's take a look at how fast the car is charging. So we are pulling approximately 115 volts at 12 amps, or roughly 1.38 kilowatts of power. For this EV, that translates to around 8 kilometers per hour of charging. If my EV is parked at home for 10 hours a day, then I can recharge roughly 80 kilometers of range every night. If my daily commute is less than this, then level 1 charging is suitable for my day-to-day needs. Do note, level 1 charging is not suitable for my daily driving needs. And so, I installed an additional 240 volt circuit in my garage that can give myself level 2 charging speeds on a regular basis. This level 1 travel cord will stay in my EV, so if I'm ever on a long trip to visit family or friends, I can grab a quick charge overnight if I need it. The 240 volt level 2 charger is typical for most EV drivers, but let's visit our office to see level 2 charging in action. This is Exergy's main office charger, or as it is commonly referred to, a quick charger. This is a quick charger for tenants of this building, and as such, runs on intelligent software that can do billing, collect usage data, and grant special access to the charger separate from the public. Let's try using it like a member of the general public. I simply log into my mobile charging application on my phone and request authorization, i.e. pay, to unlock the charging service. I then plug into the car and voila, I'm charging. Note that this charger is billing me for every minute my EV is connected to the charger. Your individual public charging rate may vary by price or may charge you by kilowatt hour. This station is much quicker than a level 1 portable cord. It is pulling 30 amps at 208 volts or approximately 6.24 kilowatts of power and is charging at 40 kilometers per hour. This is around the same speed as my level 2 charger at home. Now, let's visit a rapid charger. We are in Etobicoke, Ontario, checking out Tesla's supercharging network, which can give us rapid recharging speeds even faster than our office charger. It is very rare that I use these stations, but it is very useful for those occasional long trips. I simply walk up to the charger, detach the plug, and connect it to my charging port. Other charging networks may require users to use a mobile application, an RFID card, or tap their credit card to access the charging service. Tesla's mobile app and other networks like the ChargeLab network that is being used in Jamaica allows users to simply plug in and walk away. Public charging allows drivers access to recharging services while on the go, on extended trips, or if they don't have access to private charging at home. Private charging networks are developed and deployed for specific vehicles, whether for a private company, a government fleet like police vehicles, or a public transit agency with electric buses. These fleets will typically have their own chargers reserved for their exclusive use, giving them full control over charging cost, timing, and availability. The development of public and private charging networks go beyond just plugging in, but require the smart deployment of the right hardware and specialized software to help managers get even more value from their fleet by allowing chargers and vehicles to 1. Monetize the use of charging stations to recoup any investments, collect data for analysis and optimization, reduce the strain of electrical consumption to the public utility grid, minimize the number of chargers needed to operate a given fleet, control power flow to multiple vehicles, schedule recharging times throughout the day, maximize EV vehicle fleet availability for deployment, and monitor battery health and usage over time. I hope you learned a little bit about EV charging in this short introduction video. If you want to learn more about how EVs can impact your bottom line, feel free to reach out to the team by sending us an email at info@exergy.ca. Thanks and take care.
At this point, we have about 10 minutes left for questions. So I'll pose some questions to Mr. Babwa and Xavier, and Gary, feel free to join. Just letting everyone know that Joanna had to drop off the call. So Mr. Babwa, can you speak about the growth of the EV and hybrid market in Trinidad and Tobago? And can you also briefly touch on the cost of EVs in Trinidad and some of the concessions? You're on mute. Alice.
Yes, Nadia, sorry about that. Are you hearing me now?
Yes.
All right. The EV growth in Trinidad is very slow. And there are a few reasons for that. One is the as you said, the concessions. although we have concessions, but up to 159 kilowatts motor, which would have only given us about 2 or 3 models of the EV vehicles. That is like the Leaf, and the Ioniq. Most of the vehicle that is under that range, under that kilowatt, has a very short driving range, and with no charging ports or no grid available, it is a risk, because of the issues in Trinidad with crime and all these other issues we are dealing with. So that has complicated things, and so we don't have phenomenal growth as I thought we should have been where we should have been now, right? We need cooperation again from government with this, and then we can have real growth and savings with regards to our U.S. currency, which we import fuel now, and we no longer manufacture fuel here, and so all these things go hand in hand, right? So with the and even if we don't get the cooperation of the government, we are still out there doing it since 2012, and hoping that the consumers that can really afford these vehicles purchase them, because there will be the savings, as I said, would be phenomenal. They will have a lot of savings, because I have persons who have purchased the Nissan Leaf, and 2 years time they will come back and they'll say, where they used to put like $1,500 gas for the month, they are now using $200 more on electricity. So the savings there already is like paying back for the car. So we are hoping that we get some more cooperation from the government. And as I was talking, if we through the regional bodies and the member states, we could come together and have discussion as how we could move this whole thing of the EV forward. And there was another question.
Yeah, just on your point, that is certainly the intention to move forward as a region in terms of the regional electric vehicle strategy that Dr. Guru mentioned. I think one of the main things that people want to know is how much does an EV cost, if you have an idea of one of the models or some of the models, and also that maintenance that you did, how much does that cost?
Right, that maintenance cost. Now I was a short video, so I didn't really have time to go into details of all the other maintenance. You need to check the state of health of the battery, right? All those, so a cost for maintenance would be like about $1,000, and that would be once per year, or we would say like every 10,000 kilometers. So literally it's once a year. You'll pay $1,000. You'll have the car scanned. You'll have a diagnostic run on the car, and everything will be checked. And then the cost of one of that, because our permissible age of importation now has changed for importation of used cars from 4, which will be changed, from 1st of January, from 4 years to 3 years. So that again would cause the price of the vehicles to go up. So an EV that is about 3 years old would sell for between $200,000 and $225,000 TT dollars, and that's a used one. And with the tax that will be coming on, those vehicles would increase to about $300,000 TT dollars. So it is a big amount for if we really want people to gravitate towards it. Right? So this is why we have to bear in mind that we need the cooperation of the other states to assist with moving this forward.
Agreed. My next question is for Xavier. How can an investor in EV chargers recoup their investment in a situation where the electricity market is not open as it is in Barbados, as they would not be allowed to charge customers directly for electricity?
That's a great question. Can you guys hear me?
Yes.
Okay, great. So, I mean, it really depends on who the participant is. So utility companies have a natural advantage because they would be selling two components for public charging. They'll be selling the electricity and they would be selling the convenience. So if we're talking in the case of a public utility or someone that's licensed to sell electricity, or in the case of some jurisdictions that have allowed the sale of electricity for electric vehicle charging to be unregulated. So for instance, British Columbia, Arizona, California, New Hampshire, certain markets in the world, you can sell electricity without being an electricity retailer for the purpose of EV charging. Then it's going to be a combination of both your fuel price, which is your electricity price, as well as the convenience factor. However, in most markets, that's not the case. Electricity is regulated regardless of what its use is for. And in that case, if you're a private investor and you're looking to invest in public charging, then your business case is going to be really based on convenience, because you're not going to have any sort of advantage or control over the sale of electricity, whether you do it renewable on site, which again may be a case for the regulator to answer the question. If I put up a wind turbine or a solar car park and just sell that electricity on site for charging, does that qualify as public electricity sales? That every country is going to vary for that, but the universal part is going to be convenience. Are you putting your charging stations in a place that is convenient for users? Because users will always pay for convenience. The larger the country, the more cases you'll have for convenience charging. The smaller the country, the less likely it is that you're going to find places that people will need to charge. So, let's take, for instance, a Barbados and compare it to a Jamaica. Barbados, being a smaller country, means that someone with a modern EV with, let's say, 400 kilometers of range, they're not going to have a very high need to do public charging on a regular basis. So, the convenience factor is going to be reduced. In a place like Jamaica, where you have a much larger driving range, there may be a use case where someone is going from one end of the island to the other end. They're not close to home and they may need to recharge. And so your use case goes up. So it's a complicated answer. And, we do that work with utilities and private developers. But really and truly, you have to be looking at the convenience factor and understanding what drivers in your market are going to be doing and where, if any, use cases are going to be that you can allow them to conveniently charge in a manner that's affordable.
Thanks. And following up from some of what you just touched on, are we as a region planning for increased investments in widespread deployment of charging infrastructure to address issues of range anxiety? And secondly, what does the panel foresee as a viable revenue model for charging infrastructure? And this goes to Xavier and Gary, as well as Mr. Babwell, if you want to touch on it.
I guess I can start off. I think, interest and participation by utilities is going to be key, as well as electricity regulators, regardless of whether it's going to be a private-public partnership, a private investment, or an investment by the utility. I think engagement with them and, the Ministry of Energy and Ministry of Transportation is going to be key. So obviously the regional electric vehicle strategy is going to be talking about that and giving a template and a toolkit so that, all countries can participate in that conversation. And they can learn from some of the more advanced markets. So Barbados being the most advanced market, there's learning to be had and lessons to be learned from that. Jamaica is hot on their heels with their investment by JPS, the utility in Jamaica, to sort of get public charging up and running, to spur further investment by the private sector into the marketplace. So I would say Jamaica is probably going to be a hybrid case of that. But there are going to be cases where, for instance, in Trinidad and Tobago, that has a very strong utility sector where it's probably, black and white, that it's pretty easy for them to invest in public charging infrastructure and get it done. It's just going to be a matter of political will and aligning interests. But the use case, I think, is going to always involve utilities and regulators to be successful.
Thanks, Xavier. Gary, did you want to add anything to what Xavier just said?
Not much. I mean, the stakeholder engagement is going to be critical. I think he mentioned that the policymakers, the regulators, the utility, and the other private owner interest. The market is not exactly big, even for Jamaica. So it is really a case of how the stakeholders will come to a common understanding of what it is that we want to achieve at the end of the day. There is a competition for ICE versus EVs in terms of the other parts of it. Fuel drives some revenue for the countries, and as much as we talk about it in terms of foreign exchange depletion, It also provides a tax revenue. So there's a number of areas to consider, and the revs will be kind of looking at these different things and try to put countries in an informed decision as they develop their policy directives and the regulatory reform and what type of tariff will be addressed and how the system is going to work collectively in terms of demand response on all that level of intelligence that will optimize the operation of the grid. So there are a lot of elements, but stakeholder engagement is going to be key.
Thanks, Gary. So I'm mindful of the time and that our webinar is supposed to end at 12:30. So I'm going to pose this last question to you, which I think touches on all the areas and also would be a good segue into your wrap up. In the context of the British government's announcement of phasing out of ICE vehicles by 2030, which is an ambitious target, what is a realistic time frame for total conversions to EVs in the Caribbean? And what are the policy initiatives that are needed to accelerate the conversion? And with this question, Gary, I hand over to you to answer this and as well as to wrap up our session with your takeaways.
Thanks, Nadia. All right, so that question, good question. You know, Europe is actually looking at a lot of this type of transition. And as I said earlier, we have to be mindful that once countries are making the switch, the countries in Europe and the Americas make the switch, these internal combustion engine vehicles will become cheaper. And we have to be mindful that we don't become the dump site. So policy directions around that is going to be very important. The transition for us is not as fast, and I don't want us to be left behind. The regional electric vehicle strategy is going to provide member states with information to inform those policy directions in terms of how they are going to actually create the infrastructure and to create the enabling environment to support the development of EVs in their respective countries. Being mindful of operating in an optimal way, they would need to kind of guide those areas with their stakeholders to ensure that they have the best for their citizenry. But in terms of timing, it's something that we need to watch. We don't have a time, and I think governments will need to establish some time for themselves. They have set targets for the renewable energy deployment on the supply side. In some instances, they have set targets for the energy efficiency, but they have not really set a target so in a fulsome way for electric mobility or surface transportation. And I think that is something that they will have to do soon. And I think the REVs is going to help them to get to that position. And just to wrap up, you know, we have heard quite a bit. We have heard about the intelligence innovation. We have heard about making this particular transition affordable to our people. We want it to be clean. We want it to be safe. We want it to be all-encompassing. So the stakeholder engagement is going to be critical. The communication and public awareness, we need to let people be aware of the technology and share that information with them. SECRE has started to do that. And I think through this forum with the members here, through the distinguished panels have started to do that. We have to find the mechanism to support capacity building in the area in a very vast way. As we said, we have reached a tipping point and there are a lot of electric vehicles on the roads, but we don't think we have enough training or equipped persons who have the necessary knowledge to maintain these vehicles. And I think we have to fast track that. We have started the process by having the trainers. And the reason for doing it that way is that we want the trainers to take this information now and bring it to the auto mechanic industry in their respective countries. We also spoke about battery disposal and the afterlife for batteries. You know, that is something that governments will need to look at in terms of disposal, similar to the internal combustion engine. I don't think we have a clear framework of how we deal with commodities that we may import and have reached their end of use. I mean, some countries are dealing with computers and phones, but I don't think as a region we have holistically captured how we're dealing with technology and the disposal of that technology when it gets to end of life, and how we can actually reuse this technology going forward. So then we have to develop those very broad regulatory and policy framework to support countries as they navigate this space, providing the relevant information that will be required by them to inform them in the decisions that they make going forward, and not taking information or by shooting in the breeze before they actually can formulate those policies. We have spoke about the cost of EVs. I know it's a very touchy topic at times, but I think through the work that we'll be doing at the CARICOM, we want to go through the member states and understand what is the total cost of ownership. And we need you to help us to do that by providing us with the necessary information through the dealers, through just first owners of EVs, to understand what your insurance is, what you're paying for maintenance, what the capital cost of the car is, and just charging the car over a given year to understand what it is that cost is to you at the end of the day. And just to close off, just remember, the REVS aims, as Curtis mentioned, we're talking about intelligence, modern, clean, efficient, safe, affordable, and improving the lives of our people, because the citizens are really critical to that transformation and that transition. And just to let you know, the electric era or the digitalization era is an era of information, era of Internet of Things. And you are going to be in a more informed position in moving forward. Thank you.
Nadia, can I say one thing before we close?
Sure.
I just want to, Nadia, you see, as the UK has put a timeline when they will no longer be selling internal combustion engine, you know, like countries like in the Caribbean, like Trinidad, for example, we have not set a deadline for anything like that. We have not heard anything from the government. I don't know if other member states have made any statements with regards to that. So, you know, this might be in Mr. Curtis Voodoo Court, where, you know, he's the academia in this field. You know, they could put something out, because as dealers we could say things would be happening, but they would know more of the internal works and working closer with the government ministries, that they should give a date as to when they would like to have full electric vehicles and stop selling internal combustion engine vehicles, which would give it impetus and some push in that area.
Thanks, Mr. Bawa, and certainly this is the starting point of the conversation, and there will be more opportunities to engage our stakeholders on the issues that you and Gary have both raised. And this is actually the goal of the event, which is to bring our community together for open dialogue, to build greater awareness of the benefits of EVs and explain the technology. So at this point, I would like to close. On behalf of the organizing team and the sponsors of this event, I'd like to thank you, our participants, for attending. And I really hope that you found this session informative and worthwhile. And to our speakers who made this event possible, I thank you for all the energy and the insight that you put into your presentations and discussions. Unfortunately, we weren't able to take everyone's questions, but we hope that you reach out to us via social media, via our websites and email addresses. Ours at the CARICOM Energy Program is energy.program@caricom.org. As a reminder, these video presentations will be made available via our websites, www.energy.caricom.org and www.ccri.org. So thank you again, everyone, and I wish you a good day and a good weekend. So thank you for attending, and I'll put those websites in the chat right now.
Thank you very much. Enjoy very much.
Thank you very much, everyone. Take care.
Take care. Thanks, everyone.
Be
Bye.
safe.